Last year we acquired some technology for testing fuel cell and electrolyzer and all kind of electrolyzers and fuel cell. So I'm not going to talk much about that. Second thing is I think today in the entire day I think we have heard a lot about different technologies on powertrain, advanced powertrain. I think you all are experts on this. So again, I'm not going to talk about that. Especially I think right from Thomas in the morning he's talked about the Euro 7, then Sachin talked about EV and then followed by fuel cells and even Krishnan, right? So I think we heard a lot about the different powertrains and I think the technologies, the challenges, the developments, right? And we also heard a lot about the material development, the component development on the different kinds of powertrains what we saw today. And of course, we have seen the tools now about the physics-based models, what Ramnik just covered that. So I think what I'm going to talk more about today is especially the area in the product development space, advanced testing solutions, what Ramnik has mentioned, and how they will be mastered with the testing data management. And this is something, a food for thought. This presentation will not be anything to do with the hydrogenized engine. I will mention wherever the technology required because rest assured, I know the topic, but I don't want to bore you again, the same thing again and again. So let's start with that. So here when I talked about, or what I want to talk about the data management side, I think all of this presentation today, and even the couple of presentations what you have seen, here we are trying to solve sometimes system level problem, but sometimes a component level problem, sometimes a material level problem. But look at the OEM as an end result. They wanted to deliver system to be deployed into the market as per the market need. And when I talk about system, it's like a vehicle fit for purpose for the market. And I think there are a lot of drivers for that. The drivers are maybe about, as we said, about geopolitical reason or about environmental reason, the climatic reason, right? That's where I think we are all here to talk about advanced powertrain development. And I think one thing which I observed, which I wanted to share is, probably we look 5 years back, we were all the time talking IC engines, improvements, emissions, Euro 4, Euro 6 and not beyond, right? So the world was all towards mechanics, mechatronics, probably a little bit of electromechanics. And now what we have seen today, from the hydrogenized engine side all the way up to EVs or fuel cell or flex fuel, we will find that we are talking a lot about electrochemistry. And I think this is also the reason why I wanted to talk about is mainly that's a new field for us and we all are learning here and we are creating a lot of knowledge. So this is the idea which I wanted to cover today. So let's go in detail. One question from my side is how many times do we struggle as maybe a question like to you, for example, or your customer, when you say you want to build a system model, how easy you get the data for different system components, or how your customer can easily get the data for different system components? Can anybody answer that, especially on the model side, for example? Yeah, so many times I think, as you said, if I noticed you correctly, you said, okay, you got a model and you need to validate it, and sometimes validate with the physics model, and sometimes you validate with the real physical test data, right? And I think getting the physical test data, and this word is sometimes very, very loosely defined. When you say about test data, it's like a sheet of a spreadsheet, and you say, okay, here is my test data, and use it. And I think we all know that for generating the data, that takes effort because your design parameter changes, your control parameter changes, that impact your measurement data, and then this is where if they all are not linked, then this is where we don't get the real what we need to bring it into the models, right? So yeah, so my question was very simple, that how many times we struggle when we really wanted to solve real business problem. And today, why I want to talk about this, especially about this topic of data management, because most of you probably in your everyday work, some or other way, you always get a kind of a frustrations that, oh, I need the data, had even the data in my hand, probably I would have solved the problem in no time. And I think you all agree with me that I think some point in time, while solving some technical problem, you always come across this situation, right? And I think right now I think Ravnik also again mentioned briefly about machine learning space here. And I think we are living in a world where everybody's, I think, using AI especially about, solving day-to-day problems, right? So in that world where we are really seeing that information, especially is one of the key component of the product development process. We talked about material, we talked about talent, we talked about technology, and I think the most important aspect which connects all is the information there. And this is where the next thing will come here. I think we all know these companies, right? And I think you all will be, surprised if I am showing you this here, right? So, if we wanted to see this, what is the commonality we see in these two companies? Or what is that thing which comes to our mind that these companies, what they stand for? Can anybody try to attempt, their first impression that, okay, what company like Tesla, if I want to define, how that company can be defined, in which industry or which segment, or what they do or how they do it, and compared to what we do in automotive right now. How? Innovation, yes. How they are able to do the innovation. We all do innovation, right? What is that which we feel that they differentiate that? Because I think we know that these companies are known, I think, everywhere in the world right now. Especially if we look at from the Tesla side, we see, okay, we have seen it. They changed the landscape of electrification of the vehicle, for example. And the good or the worst case, they were not extinct 30 years before, right? So they were able to do this within 30 years. So what is that which they try to brought into their product development process, which we are missing? So this was the first point. Another point, if you look at Amazon, for example, right? Again, we know Amazon for the book selling company right from the beginning, right? And today, if you name it, the number of industries there right now. So the food for thought is, I think there must be something which we are missing probably, or which we maybe think that we may be overlooking it, or maybe we take it for granted that it's done only this way, right? So I think I will get some answer in this in my presentation. I try to bring some of the ideas. And please, this presentation is mainly about a kind of a retrospection or introspection or a future prospections about what thing is missing there and how we can. And I'm saying this from my 25 years of experience. And when I started the work there, I always used to wonder that what is that which is missing, right? And I'm unable to get that answer at that time, but I think today maybe we'll try to get some answer here. And that's where we are talking about that, whether this is a revolutionary thing. Probably end of the presentation, maybe you decide whether it's a revolutionary or a normal one.
I think they have a distinctly different and unique business model.
This is one, but again, if you look at I think you get the answer here. They learn, adapt, and implement quicker and better than others. The reason being is, if you set up a complete infrastructure, right from your manufacturing all the way up to deploying of the software into your vehicle, right? Which is we talk about over the air, right? So if you have these and you are getting, as you mentioned about the telematics, for example, you're getting the continuous feed back into the system and then looking for the test scenarios, and you see which scenarios you have not tested it, bring it back into your physics loop and test it and then deploy it, right? So this is one of the, I think, mentioned is about the innovation and how they do innovation is with this approach probably. Yeah, so what I was really trying to bring onto our table, see, because I just said that, as a technology, you all are experts, you know your innovation is better, but what I was trying to bring a completely different perspective, that how they could do innovation faster, and we are living into an age of information where how we can do the same, right? So, as we have said, and again, this is an important point, what even Ravnik also, you also mentioned about the continuous feedback loop. Now, there are various kinds of feedback loop in the entire vehicle development program. I'll come to that later. But so, what difference we are doing compared to them? I mean, this slide will try to give you a very, very vague idea that it's almost kind of like a linear and a structured thinking. And here you see is everything connected, right? Everything connected. Now, why this is important? Because we always see our data just from the one single viewpoint, right? We see from multiple viewpoints. If I do a design variations, I would like to see different way. If I want to control a parameter variation, I see it different way, right? So I think this is one area, what we found, that could be a differentiator for us. And I think probably, we'll see some of the cases of success as well as failure, and I think I'll come to that. So this is what is the feeling, in general feeling, with the current state of information technology right now we're talking about, that intelligent feedback loops. The company followed that at 50% more likely to reduce the product development time by 30%. And I think probably a company like Tesla has set that kind of an example, that how you can bring the model consistently, reliably, high performance, and with the minimum issues, and again in this era of software-defined vehicle. Right? So I think this is one important point there which I wanted to mention. Probably we will see this, and again fundamental question is same. In our day-to-day work, are we struggling, or is it hampering? Is our product launch or is our product deadlines are getting hampered just because we don't have those internal closed feedback loops? So I think maybe if anyone who can just resonate with this problem in day-to-day life when they're trying to work on, I would like to hear that.
One more thing I would like to add, related to the Tesla example.
Yeah.
Specifications, features, and the performance, what they have offered, customer is ready to pay extra premium.
True, totally right. You're absolutely right.
It's not like that customer always want a cost-effective product, but if it gives a real value addition, people are there to pay extra premium. That's what exactly Tesla is doing.
Absolutely, and I think this gets to the point that if you look at Amazon and Tesla, look at the customer interface. The most simplified customer interface is that customer get experience of that product seamlessly. Exactly. So you're spot on, and this is where I was coming to, that we are living in a world, especially in automotive world, the most complex area, right? We're talking about vehicle, we're talking about 5,000 different components coming together, different controllers coming together, different parameters coming together, and that's create an ocean of complexity. And how we can manage that complexity so that we can really bring down the product development cycle, and whether that can be revolutionary. So this is where I was coming to. So, interesting point here. We know all these companies, right? There's a Boeing, Airbus, Toyota, this model, Volkswagen, right? Now, there will be a next one, to give you an idea. This. I think there was some research trying to find out that which all, these are all known companies, very big companies, but even there are delays everywhere, right? So you see there, the delays cost money, right? Everywhere. We will come to that why and what could be the reason that if these companies are so good, if the companies are implementing best of the best tools of the IT technology, still they are not been able to master this, right? There must be something which is missing. Same case with Ford. I think this was a very famous story, especially about the EV launch. So these are just a couple of examples which made me think that, okay, if these companies are there, they are so big, they have big IT departments internally, they have big PLM. I think the PLM has originated at Airbus, if I remember correctly, many years ago, where they're really talking about the complete traceability of the product, right? Still we miss. What is that what we are missing? Or what is that which these companies are missing? Big companies, right? Big losses. There must be something. So here, this is where the point is, the list is like, endless, right? I think probably we might have seen a lot of industrial and actual engineering use cases where we see that these things happen every single day. And I think if you look at the root causes, right? Let's see what the root causes looks like here. Now this picture gives you a very high level view about, if you see, development test over wasted R&D, extended R&D, software issue, redesign, delays, right? And they all lead to your product launch inefficiencies, right? So, if you see the disconnected data silos, this is what I think you mentioned there about the silos, and this is exactly what we're talking about, and this could be the reason. Any inefficient testing feedback among complex data management. So this is what I meant by intelligent feedback loops. And I think there are technologies available, and this is where I promise you I'm not going to discuss anything about my product. What we are really talking about are core fundamental issues which I've seen in most of the technical conferences around, detailed technical presentations on this, but on the core on which we are developing the technology. In fact, I always ask many people that, okay, you invest a lot of money in the test equipment, right? What is the outcome of the test equipment? It's the test data, right? What are you doing with that? Nothing, right? Nothing. Absolutely. If you ask anybody, they will say, I will spend, hundreds of thousands of dollars of setting up the test bench. But if you ask me, no, this is an engineer job, and engineers are still working with Excel sheet, right? If you go to any company, right, everywhere you will find that an engineer who is the most precious, highly intellectual person, when he would like to work on the data, we are talking about latest and greatest IT technologies for normal user, but for the engineer, he still have to work with Excel. And the reason, this is where I was coming to that, why these feedback loops are so important there. So again, the same question. Again and again, this question will come in my presentation, that is it hampering the growth, right? Or let's put the question in the other way around. Is it this question which we ever thought about it, or we simply don't care about it? There could be two possibilities, right? Because we are in day-to-day work, we are so much engaged in our own core work that we really don't see whether information or these closed loops can play a significant role where I can reduce my development time faster. So there are some case studies, again, since morning, I think it's very interesting. I think we all know about cafe, right? We discussed in the morning about the word cafe, right? But this is not this cafe, what I meant. This is not the one I'm talking about. This is the one what we hear in the morning. Even the presentation before from Bosch, or maybe, from Toyota in the morning, that if they do flex fuel and how they can get corporate fuel, average fuel economy. Now, a very simple use case. You can imagine if a company, like take a case of Tata Motors. I'm sorry, I'm taking some example, but please don't get offended by this. But what I'm trying to say is, if they wanted to predict, if they want to give a cafe value to the government, do you know how much number crunching they will need? Can you imagine? Let's break down into the pieces, for example. For a corporate average fuel economy, I think we all know that in India we are talking about CO2, but in US they're talking about gallons per mile, right? What they say, Tata Motors, if you are delivering 10 different models, my average fuel economy or average CO2 cannot cross this. Now, you can imagine Tata Motor being the company, if they have 10 different models, not every model will sell highest, let's say Nexon is the highest seller, for example, right? So, how this change when it comes internally to the development team, and they say, can you reduce the CO2 for this particular vehicle by X amount? Or if they wanted to create two scenarios, coming back to your point there, that if I want to reduce, what I need to do in my powertrain? Which particular vehicle I wanted to bring it down, right? Those are the questions which the business asks. And in fact, all what we are doing is actually what coming from the marketing side, okay, what product the market needs, right? And then it is driving, then you have regulations, then you have government regulations, and then you wanted to address the technical questions. And if you want to address those technical questions, you need technical data. And this is where I'm saying, to solve this problem, you need a powertrain data, you need a drive cycle data, you need a transmission data to calculate a fuel economy in a simulation. So if you want to do this simulation for one model, you need to collect data from all. And you can imagine that if I want to collect data from all, one is sitting in the transmission department, one is sitting in the vehicle department, and if I don't have data as a data, I have only documents, right? And I cannot calculate the fuel economy with the documents. I need data. So this is where is one of the examples that why a closed loop feedback is so important as a business for Tata Motors. If they want to predict, if they want to direct the development, we discussed about the flex fuel and the subsidized, the benefit coming in from the government side, and how you can reduce so that you can get those kind of benefits, right? So this is what is the use case. Is a closed loop. Headache, right? So, these headaches, I think, especially for the leaders who are, deciding at the vehicle level or at the, probably I can ask Krishnan, maybe he will be able to synchronize with me for sure, because they are living this kind of headaches every day, right? use case. I think again coming back to your use case. Your use case about if you want to do thermal management. Now I go a little bit technical because I feel that if I talk to business, I will be too boring, right? So I'm coming back to the technical now. If I want to improve the thermal management system of a battery electric vehicle, what do I need? Can you imagine what are the different data you need? Real world example. You need the data from battery, you need data from motor, you need data from transmission. For thermal, you need a refrigerant coolant, drive cycle data, controller, design parameter variations, and of course, all the time in the engineering we do trade-off, right? Do I do a fuel efficiency improvement or thermal management or my energy consumption, right? So I need to balance all. I need all this closed loop. I need all this closed loop. I need a connected data. I need this knowledge how the data is connected so that I can solve this problem. I am not the expert of the models, but I know what is needed from different groups. And you can imagine there is one thing what we are missing. The thing what we are missing is we assume that the data what we collect in the physics model or a model is fixed, which is not true. You change a variation, your physics model data will change. And that's where you have a complexity coming in there. And this is where I really strongly encourage that. I always believe that this is a kind of a platform which we need to think, and these are the tools which are there which get integrated, and they should be able to get this data or variations as soon as possible. Or they know exactly what data is coming in from, with what variations. And when we talk about the simulation, I think this is one very important aspect what we also need to see. Yes, anything which I make based on the engineering principles, I can simulate physically, but what about the environment simulation? And this is where, again, it's linked back to the topic of combining the physics-based model with the machine learning models. We have seen numbers of examples, especially about weather predictions and all, where they say, yes, I have an excellent mathematical model, but I cannot do prediction by more than 4 or 5 kilometers. Reason, and I think there are some very good examples I've seen there, that you need this. So now let's talk about the solution. I'm talking all this with experience that I was watching automotive industry since 1999. I'm sorry. And I come to a point where I always used to wonder that why in any automotive R&D, 6,000 engineers are working or 10,000 engineers working, and they're all working with their own tools there, and why there is no connections. Why? Either it's not required, or people don't care about it, or it's fine. So coming back to this is a very important aspect what we have done. I will come to that, the use cases which I have actually tried these kind of examples and what problem we were trying to solve with this. But this gives you the idea. The very first thing you need a centralized and standardized test data management. Now, this is again a word of fallacy. When I say about test data management, different people have different meaning to this word. Few people say that, okay, I just do a testing, I have a test lab, I collect the data in one particular server, I collected all the documents, and this is my test data, right? This is not what test data is. The test data is real engineering values as a values. And what changes you do and how you bring them together, that's what the test data is. The second, the most important piece of the puzzle, when I talk about the closed loops, anybody has ever heard about graph databases? You use it every day. How many of you are on LinkedIn? What the LinkedIn does, right? You connect one person to another and then you see the link and this is what, right? So that means what you are doing there in the graph database. Have you heard of knowledge graphs? You know how we represent the knowledge. Oh, this is connected to this is connected to this has this meaning, right? So this is the very, very important piece of the puzzle, and I always wonder, nobody talks about it. If you talk about anybody about test data management, they talk about database, they talk about Oracle, right? Nobody talks about this. And this is the most important piece of the puzzle, because this is where we see how you are able to manage the complexity. Because you know your different vehicle components, how they're connected to each other. You are making a design structure matrix where you see the dependencies, right? So, a very important piece of puzzle. And of course, I think you already answered that once you have this infrastructure in place, Then you are applying all your latest and greatest machine learning tools or AI tools on top. So first you really need to base the foundation in place, then you get things connected, and then you are using it for predictive. So I think this is not a one-day job, but you really need to plan. So what is missing? Coming back to this problems of delays, right? What is that one thing which is missing? Probably most of you or all of your companies, you always see, okay, when I come to this topic, a most obvious answer come to me is, oh, I have an IT department who takes care about this. The second thing what comes in my mind is, oh, I have a tool like PLM who takes care about it. Now mind you, I gave those example of big companies. They already have PLM tools. They already have IT department. Still there are delays. So what is missing? Can we think about like how we develop a vehicle with a kind of a platform approach? Can you think that you need an information platform? Can you think about it? Just a food for thought. Can you think an information infrastructure? Because I've seen some use cases where how we use this tool of entropy in mechanical, like how the entropy gets increased when the system gets unstable. Have you heard of this word information entropy? Now those are the things which they try to do with this. And I think if you really want to do this is the piece of puzzle which is missing. And what you really miss in all your companies are a good information architect who can really see a kind of a data modeling where the different kind of things are connected. Then again, you need a kind of tool where you need to standardize and you can take the data. So I think this is an important aspect which is, I think I already given lots of examples on this about how this thing works, right? So the idea was very simple. And if we do that, and if everybody, then they can work only on pure innovation. They don't need to worry about the data is coming about, do I need to convert the data, do I need to convert the data for the tool which I need? You don't need that. So, does it remind someone? We have seen this, right? So this was the answer of the first question which I said, what are those companies that are doing which we are not doing? So my message was very simple. Think from data, and I think, mind you, I think there's one more important aspect what we all hear about machine learning, right? Machine learning are data hungry, right? And we know that we are the companies who are generating tons and tons of data, tons and tons, in every single department, in every single testing, right? We are not able to use it. Why? Today if you go and ask that we test, okay, I don't know if this data is there, probably I'll retest it, right? Common. I think most of you might have seen this problem, right? Only reason is this. So you see the amount of cost what we are losing there, right? Few stories, but very short. Probably you know this company. We work with them from India in the IT domain. Especially I talk this example mainly because of emissions regulations and emission compliance process. Now you can imagine this company, 2 brands, multiply by the number of models, multiply by the number of countries where they are selling. Can you imagine what level of certifications they need to do? I'm talking only about emissions. Plus, number of people working on this. Completely different compliance teams, complete development team, complete COP teams, right? Production happening somewhere else. How you are ensuring that each and every model what you are releasing and launching and new COP, you are not risking yourself for recall. This was a case where you can imagine what all connections you need. You need a type approval, you need a development, you need to connect back to the production, you need to the COP, you need a regulatory processes, plus the regulatory process are continuously changing. We have discussed that, right? So in this dynamic world, if you really wanted to solve and really wanted to solve the problem, this problem is not for them alone. I can tell you this problem is there. You go to every single OEM and probably we will find this problem everywhere. So I think this is one very interesting case we try to solve. And I think my customers right there at ARAI, I think we were doing for since 2005. Because before that all the calculations were manual, and I think since 2005 emission regulations completely automated all the way up to Euro 6. So that every single 2, 3, 4-wheeler, you talk about the commercial vehicle, passenger vehicle, all regulation, all certifications, all calculations on that. So, done? One more. This is the last one about the use case in Japan. I think again we know this. This is where I learned a lot. I'm working with them since 2010. They never seen test data just for automating the test report generation process. They said, can it solve my business problem? And this is where the example of cafe coming in. Said, I'm selling in US. I know my CRV is selling more there. Can I reduce my Civic CO2? Can I reduce my Civic fuel economy, for example? This is just one, but here, powertrain department, 17 different function group, right from performance, durability, noise vibration, NVH, CAE, all connected through this connected feedback loop. And their idea was how they can replace it. They can go towards the model, which is a truly digital twin, where they can pull the data from any sources and build it. So it's not just for fun, the test data management, but it's a strategic dominance, right? Anybody who can really master it, they do it. So you can think about how you want to reverse. So I don't know, the choice is yours, whether it is a revolutionary thing for managing the data or it is just an incremental. So I think that can give you a very, very broad perspective on how we can look at the data or whatever we are engineering work what we are doing and the data what we are generating, how to respect that, right? So feel free. We do a kind of a lot of strategic consulting to all these companies what I mentioned there. We actually gave them the strategic consulting that they came up with this idea. They said, okay, we are all engineers, we are not IT, but our IT is very difficult for them to understand this, so we bridge that gap. And we play the role of the information architect, and then we develop these kind of things which are like a repurposing. So, thank you very much. Any questions, please feel free. I'm not sure whether I've taken more time or less time.
No, I think you're right in time. Thanks for that. Maybe we can take a couple of questions, real quick ones, if we have any. Okay. Good. I take that as maybe it was clear in the first place itself. So I'd like to request Mr. Dr. Chandrakant Aute sir from ARAI to come up on stage and illustrate Mr. Puran Parekh sir.